to the world of biomechanics. Today we are on Module 6, where we will be talking about power. Alright, so let's get started. So when you think of work, you probably think of someone behind a desk, making money, doing their 9 to 5 job. But in physics, power is the rate at which work is done. If you remember from last module, work is a force applied over a distance, which, can't be done without energy, obviously, whether it be kinetic or potential energy. Okay, on to the SI unit. So the SI unit for power is a watt, named after the handsome man on your right, which is Mr. James Watt. He was a Scottish mathematician and engineer in the late 17 and early 1800s. Fun fact, Watt specialized in steam engines. He saw that repeatedly cooling and heating the cylinder in the engine as a source of energy was a waste of time. So Watt, the smart guy that he is, came up with a new invention called the separate condenser, which avoided such a big waste of energy. Also, a watt is equal to 1 joule per second. Okay, so now for some really deep thinking here. So the formula for power is equal to P equals W divided by delta T, or in other words, power is equal to the work divided by the change in time. And to solve that, you'd have to know that work is equal to force multiply the change in displacement. So for my story problem, I decided to lift two weights that equaled 10 pounds together, and in kilograms, it's about 4.5. I lifted them about 2 meters, and it took me about a second to do it. To find my force, I took 4.5 kilograms times the force of gravity, which is 9.8 meters per second squared, and I got 44.1 newtons. Then I plugged that number in to find my work, and I multiplied that by 2 meters to get 88.2 joules. And finally, to find my power, I took 88.2 joules divided by 1 second, which gave me an answer of 88.2 watts. Thanks for watching.